SwayamPrabha. Digital India. Educated India.
Good morning and welcome to this next lecture on vibrations of plates and shells. So we are looking at forced response. Within that we are looking at steady state harmonic response, where the effects of initial conditions have decayed away, okay, and the steady forced response remains. Okay. So now let us look at the response to a few forcings. Now the first of all, let me set my geometry straight so that we will look at several examples here. So let us say this is my x, that is my y, and that is my z. Okay. In terms of our original systems, it is alpha 1, alpha 2 and alpha 3, okay, we should not forget. Okay. And then I will write the equation of motion in the way normally you will see it, plus 2 del 4 w by del x square del y square plus del 4 w by del y 4 plus rho h w double dot is equal to the force. Okay. Now let us look at D. D is what? E h cube by 12 into 1 minus mu square. So in terms of mass, length and time, the fundamental units, E is what? Newton per length squared, and Newton is what? Mass into acceleration, and further mass length squared, L squared, okay, and this cubic in length, say L cube. So this is what? M L square by T square. Okay. Right, Newton mass into acceleration, m into L by T square, and length squared, and h cube length cube. So 4, yeah, ml square by T square. Okay, that is my D. Further, what I have this term over here, this is single w length, single length over length 4, length 4. Okay, so that is equal to m L cube by T square L4. It is m by LT square. Okay. So if I write it in terms of a force again, my force is what? M mass into acceleration, okay, ml by T square, and this has L in the denominator, so into 1 by L square. So this is force per unit area. Okay, till this point was D. Okay, then I have included this term over here, which is that term over here. It results in this term. This I have further broken into a force, and what remains? So this is a force per unit area, force per unit. So, this term has force per unit area units. Okay. Next, let us look at this term. So, similarly this will have force per unit area, force per unit area. So, the equation is balanced in terms of units. So, let us look at that term. So, we have rho, which is mass per unit volume, then h is a length, then we have acceleration L by t square. So, this is what again m L mass per unit volume into length, acceleration is length over t square. So, this is again m by Lt square, just like this. Okay, this is also m by Lt square, which means what? It is force over area, force per unit area, and therefore this force has to be force per unit. Q3 has to have units of force per unit area. So, if you are going to apply a force, then it should have force per unit area dimensions. Okay. So, units is important, one thing, unit is important. Okay. What is the second thing that is important? It should describe the nature of the force, describe the nature of the force, nature of the force. Okay. So, now if let us say I apply a certain force, apply a certain force, F, let us say, over a, let us look at one dimension, okay, and that is applied over a length. Okay, that force is applied over a length. Okay, such that the total force over this length is the same. Okay, that means what? I have a length unit, let us say L, and I have a force per unit length F by L. Okay. So, force per unit length is applied over this particular length, so that the total force is F. So, if the length is made bigger over which it acts, let us say this is L1, this is L2, longer length, then this is F by L2, which is smaller, but the total force remains the same. Okay. So, now what do we do? What we have is that suppose we want to apply over a very small length, very small length. Okay. Then what happens is that as my length starts to shorten, over a short length I get this much, over a shorter length my force per unit length goes up as, okay. So, I will call this epsilon, I will call this 1 over epsilon or F over epsilon. In the limit what happens is that epsilon will tend towards 0, and then F over epsilon will become, start tending towards infinity. So, epsilon will tend towards 0, and f over epsilon will tend towards infinity. However, in the integral, which is, let us say, x star minus epsilon by 2 to x star plus epsilon by 2 dx turns out to be f. Okay. So, the function itself, if you look at it, will blow up. However, under the integral sign it gives the value f. Okay. So, this aspect is represented as f delta of x, where delta x is the Dirac's delta function. It is undefined at x equal to 0, where the argument goes to 0, it is undefined. However, under the integral f delta x dx, it turns out to be f. Okay. On its own, if you write f delta of x, okay, it is undefined at x equal to 0, where we are interested in. However, if we integrate f delta of x dx, okay, from 0 minus to 0 plus, that is equal to f. Okay, that means the integral of delta over 0 minus to 0 plus is 1. Okay. So, now if f times dx integrated is equal to f, then the delta x has units of 1 by length or 1 by x. There is f over here, there is dx over here. So, if f times dx is a unit, but after integral it is still f, therefore, delta x must have 1 over dx units, okay, 1 over length units. Okay. So, a point force is described in two dimensions. In this form, the force amplitude delta x minus x star delta y minus y star, wherever it is applied. The force is applied at x star and y star, x star comma y star. Okay. So, on the plate the force is applied locally at a point at x star comma y star, and it is described in this fashion. Okay. So, now the descriptor is okay, it is describing a point force. What about the units? Well, we said delta x has 1 over length units. So, this delta x has 1 over length units, this delta y has 1 over length units. So, 1 over length square units, this has force units. So, together they have force per unit area units. So, that is also satisfied. Okay. So, now what? I have d del 4 w del x4 plus twice del 4 w by del x square del y square plus del 4 w by del y4 plus rho h w double dot, and the force now F delta x minus x star delta y minus y star e to the power of j omega t. So this is my Q3 star. This is Q3 star. Okay. So if Q3 star is known, now the procedure is very straightforward. What did we say? So if Q3 star is known, multiply by the mode shape, get Fmn star. If Fmn star is known, gamma tilde Mn is known. If gamma tilde Mn is known, eta Mn is known. Okay. So let us look at Q3 star here. Okay. So now what is F? So we have a simply supported plate. Okay. So we are going to look at plate is simply supported. That means my phi Mn is sine m pi x by a sine n pi y by b. Okay. So given this Q3 star, let us find Fmn star. Fmn star is integral 0 to a integral 0 to b f delta x minus x star delta y minus y star e to the power of, we can ignore that e. In this form Fmn star is just a number, sine m pi x by a sine n pi y by b dx dy divided by rho h n mn. Now what is nmn? Nmn is, for this simply supported plate, it will be the same for all cases, integral 0 to a integral 0 to b phi mn square, which is sine square m pi x by a sine square n pi y by b dx dy. Okay. So that gives me integral 0 to a integral 0 to b 1 minus cos twice m pi x by a by 2. Okay. And 1 minus cos twice n pi y by b by 2 dx dy. Okay. So now they are separate. This is an x integral, that is a y integral, and these goes to 0. Okay, if you do not believe me, you can try it out. So only 1/4 remains. So integral 0 to a integral 0 to b dx dy by 4, which is ab by 4. So that is nmn, as long as we are in a simply supported plate situation. Okay. So now let us look at Fmn star. So this is a delta function. Now if you are familiar with delta function, it has the shifting property. Okay. So it is 0 everywhere and undefined over here, x equal to x star, and it works only on an integral. So without elaborating, I will get f mn star as f and the value of the function at x star sine m pi x star by a sine n pi y star by b, and nmn is ab by 4. So 4 by A B rho H, that is my Fmn star. Okay. Once Fmn star is known, let me remember that, 4f by A B rho H, 4f by A B rho H, Fmn star is equal to sin m pi x star by A sin n pi y star by B. Gamma tilde mn now is equal to, without writing it so many times, Fmn star by omega mn square minus omega square, okay, plus j twice zeta mn omega mn. Into omega. Okay, that's good enough. Okay, that's good enough. So now my eta mn is equal to gamma tilde mn e to the power of j omega t, and therefore the response w x comma y comma t is equal to, let's see, 4f by A B rho H sin m pi x star by A sin n pi y star by B divided by omega mn square minus omega square plus j 2 zeta mn omega mn omega okay. This is gamma tilde mn into e to the power j omega t, that is eta mn now, and summation over m and n eta mn into phi mn. So sin m pi x by A sin n pi y by B. Okay, so that's the story. Oh, sorry. Okay, so this is the response to a point force. Okay, next I'll just say this here, that please take a note that there is no m or n standing out. There is no m or n here in the numerator or m or n standing separately out. Okay, so that is for a point force. Okay, we will comment on that little later. So the next force we will see is a response of a simply supported plate to a uniform pressure. Uniform pressure. Okay. So what do I mean? I have a plate over here simply supported. This is X, that is Y, this is Z, this is the A dimension, this is the B dimension, okay, and there is a uniform pressure acting over the plate over some region, over some square region. Okay. So now suppose the total force is F, okay, and then this happens to be from A1 to A2 and B1 to B2, okay. So then the pressure, okay, the pressure let us say this length is A star and this is B star, okay, A2 minus A1 is A star and B2 minus B1 is B star. So the pressure related is F by A star B star, okay. So that is force per unit area, okay. So already the area we have matched, okay. So if I have the plate equation d del 4 W etc. plus the mass term is equal to the Q3 x comma y comma t. So we have F over A star B star, units is matched, and of course the harmonic part will be there, e to the power j omega t. Now the spatial extent has to be given. The spatial extent is given by h of x minus A1 minus h of x minus A2. So that describes the x direction multiplied by h of y minus B1 minus h of y minus B2, okay. And the Heaviside function has no units, so the units are matched here, the spatial description is matched over here, okay. So now we have the Q3 descriptor, okay. So what is Q3 star? Q3 star is F by A star B star Heaviside x minus A1 minus Heaviside x minus A2 then h of y minus B1 minus h y minus B2, okay. And therefore F m n star is equal to F by A star B star rho h n m n integral 0 to A integral 0 to B Q3 star into, okay. So h x minus A1 minus h x minus A2 into h y minus b1 minus h y minus b2 into sine m pi x by a sine n pi y by b dx dy. Okay. So now what this Heaviside function will do is, it is 0 outside a1 to a2. Okay. And therefore it will allow any non-zero value only between a1 and a2 in the x direction, and b1 and b2 in the y direction. Therefore this integral now becomes, okay, 4 by rho h a b, okay, into f by a star b star integral a1 to a2 integral b1 to b2. Okay. Then the Heaviside is taken care of. Sine m pi x by a sine n pi y by b dx dy. Okay. So how do we do this? So we have 4f by rho h a b a star b star. X and y are separate integrals, so I get minus a by m pi cosine m pi x by a from a1 to a2, and again minus b by n pi cosine n pi y by b b1 to b2. Okay. So this is what 4f by rho h a b a star b star a b by m n pi square and cos m pi x, sorry, m pi a2 by a minus cos m pi a1 by a, okay, into cos n pi b2 by b minus cos n pi b1 by b okay, that is your fmn star. Fmn star. From here to gamma mn, gamma tilde mn is fmn star. I will not write it the whole thing. Fmn star divided by omega mn squared minus omega squared plus j to zeta mn omega mn omega, okay, and then from here eta mn and then w x comma y comma t. Okay, so that should be simple enough. But what is important here is that this has and m and n in the denominator, the mode numbers in the denominator. Okay. That means what? If mode numbers become higher, then Fmn becomes small, response becomes small. Okay. That means what? The pressure prefers lower modes. If you apply a pressure in general, you will get a high response at lower modes. Okay. Whereas if you remember, this is the response to a point force. There is no, I deliberately said neither Mn is there in the numerator or denominator. So point force, let me write it here, prefers all modes equally or affects all modes equally. Okay. Whereas it is different with the pressure. We are run out of time, so I will stop the lecture here. We will continue from here next class. Thanks.